The electromagnetic spectrum. This diagram shows the family of waves that make up the electromagnetic spectrum. I've shown the wavelength in meters at the top of the chart and the frequency in hertz at the bottom of the chart. It goes from radio waves at around 10 to the 3 meters, about a kilometer and beyond, up to microwaves around about the centimeter wavelength, infrared, visible, ultraviolet, X-rays and gamma rays at 10 to the minus 12 meters, about 100 times smaller than the nucleus of an atom. The frequencies range from 10,000 Hz here, 10 to the 4 Hz, up to a massive 10 to the 20 Hz. As we go from left to right on this chart, we're increasing the energy and the danger of the radiation. You'll also notice that as the wavelength reduces, the frequency was increasing. These are linked by the equation C equals F lambda, or wave speed is equal to frequency times wavelength. Wave speed for all the members of the electromagnetic spectrum is 3 times 10 to the 8 meters per second. As well as travelling at the same speed, all the members of the electromagnetic spectrum have other similarities. They're all transverse waves. They can all travel through a vacuum, and they all consist of a changing electric and magnetic field. They differ only in wavelength, frequency, and energy. Here are some of the uses of the members of the electromagnetic spectrum. Radio waves are used for broadcasting and communications. Microwaves are used by mobile phones, by microwave ovens, radar for finding the position of aircraft, communicating with satellites, and by satellite navigation or sat-nav systems. Infrared is used by heaters, grills, barbecues, night vision equipment, security systems, and by remote controls, for instance for the TV remote control. Visible light is used for sight and for photography. Ultraviolet is used for special effects, for instance in nightclubs, for sunbeds, and for checking forged money. We cover ultraviolet in a little bit more detail in a moment. X-rays are used for imaging the body, for broken bones for instance, for checking luggage at the airport, and for analysing the structure of crystals. Gamma rays are used for treating cancer, a radiotherapy treatment, and for examining structures for faults, such as in metal structures, rather like X-rays are used on the human body.